Hi students, so we are back in the second part of the lecture for Z transform. So this is the Z transform pairs. In the table you can see there's three columns showing you the sequence and the transform, the Z transform and the ROC. So in the sequence, okay, so for the first line you see that delta n, the Z transform is 1 and the ROC is all Z. Okay, and sequence UN, Z transform is given as such and ROC is Z bigger than 1. Okay, and so it's so you see this several Z transforms. Okay, so you don't have to remember the definition, but you can just simply refer to the table. Now okay, so if you can see in line 2 and 3, okay, the sequence is different but the Z transform is the same. Okay, the only way that one of the way that you will know if you want to do a Z transform and then you nak buat inverse Z transform. Okay, so from the Z transform ni, okay, you are given the ROC. So from the ROC you will know whether you have to use the second sequence or the third sequence. Okay, so but the ROC dia different. And if let's say you are not given any ROC, or you are not given, say that okay, this is a left-sided sequence or this is a right-sided sequence, okay, or this is causal or anti-causal, so you have to use the first one lah in the table. Okay, so for instance in you're given a Z transform, okay, and then doesn't say that you have to find sequence yang mana, so you just use the first sequence. Okay, this is throughout the table. Okay, now there is a second type of Z transform table. So that if you baca literature or you refer to other books, you'll find that there's a Z transform table that uses the positive power of Z. Okay, so there are two tables lah. Okay, but we mainly refer to the first table. Alright, then this is the Z transform table of properties. Since we don't have to derive anything, so you just need to understand the tables for easy reference. Yeah, so for xn you dapat xz and ROC dia adalah rx, and x1n, so ROC dia adalah x1z, Z transform dia x1z and ROC dia adalah rx1. Okay, and x2n, x2z, rx2. So linearity, okay, if you this is yang kita dah pernah jumpa sebelum ni, a x1n plus b x2n, so you have a x1z plus b x2z. Please note here that the notation of the Z transform, they use a capital it uses a capital X. Okay, for the sequence is small x. Please buat dia punya differentiate between the two, okay, so that you tak confuse nanti. Right, so the ROC is the overlapping region of Rx1 and Rx2. Time shifting is X and M. Okay, so you shift ni, kita dah tengok sebelum ni, so the shift you see that Z to the power of negative M xz. So dia punya ROC adalah Rx except for the possible addition or deletion of the origin or infinity. Okay, depends on dia punya apa tu dia punya sequence. Yeah, so so sometimes most of the time dekat Rx dia the ROC of this Z transform, dia punya origin tu tak termasuk dalam ROC dia, atau infinity tidak termasuk dalam dia punya ROC. AN, XN AN, XN gives you XZ over A. So ROC dia adalah A times Rx, and then you have differentiation Then you have conjugate, time reversal, and convolution. Yeah. Alright, so we look at another example of Z transform using the table. So you have xn and you have here 1, 2, 3. So 3 terms dekat sini. Alright, so you have to approach this term by term. Jangan terus tengok ni gabra. Okay. So you have the first term, and then the second term, and then the third term. Okay. So here we'll simply refer to the table. Okay, so from ZT pairs line 5 and 6, line 5 and 6 kita refer dekat situ. You see that the first term, okay, the first term ni, right, is similar to this one. Okay, the UN dia pun adalah UN, this one. And the second term is also the same. Alright, and then the third term adalah line number 6. Okay, so when you buat dia punya Z transform, so XZ, okay, Z transform XZ, so you're going to transform Z curly brackets ni on all these terms. So you buat tulis begini, so Z transform of first term, Z transform of the second term, the third term. Okay, so how you write it is, okay, yang dua ni letak dekat luar lah, we just focus on this part. Okay, yang tiga ni pun sama, focus on this part, and this one is on this part. Alright, so you nak tengok, you just refer pada table. So A would be ni lah, negative 1 over 2, okay, negative 2 over 3, and then this one is 3. Alright, so boleh, then you just simply buat dia punya tuliskan dia punya Z transform. Okay, and then once you get your Z transform, okay, ni dah siap dah yang tu. So this is what you get, alright, and then you can stop until yang you dah siap ni lah Z transform dia, because you can see already dia punya poles. Okay, you can see dia punya poles, but you can also write it as such. Tak ada masalah. So this is okay, this is okay. Now you keluarkan dia punya poles, okay, dia punya poles and dia punya ROC. Okay, so you have the first and the second term is this kan, Z bigger than magnitude A, Z bigger than, so this is bigger than 1 over 2, bigger than 2 over 3, and this is smaller than 3 because of this. Now, note dekat sini, you don't have to be so concerned about dia punya plus minus tu, because dia nak magnitude saja, magnitude. Right, and then what you do is you draw the Z plane. Okay, so you draw you punya imaginary axis, you punya real axis, and then you draw your your unit circle. Okay, unit circle dulu, and then you draw for poles yang pertama 1 over 2, okay, 1 over 2, then you draw the second pole 2 over 3, okay, this is you punya the looks of your Z plane. Alright, okay, then you kena buat lorekan. Okay, you have to lorek the area of shade the area of the ROC. So for the first one, okay, is the ROC is bigger than 1 over 2, so everything is outward lah. Okay, so this is bigger than 2, so everything is outward. Okay, outward, all the lorekan is outwards. Okay, you tak payah bawa pencil color ke apa, just simply lorek like that, just to show it is outside of 1 over 2. And then for the second pole is bigger than 2 over 3. So bigger than 2 over 3. So you lorekkan kat luar 2 over 3. can draw like this. Okay, nak shade macam mana lah, asalkan you can show that it is bigger than 2/3. And then you see that Z is smaller than 3, so it is inward, so it's within the circle. Now we need to find an overlapping region. Okay, so the ROC, okay, the final ROC is an overlapping region. Kat mana yang dia overlap? It is actually between 2/3 dengan 3 lah. Okay, sebab itu yang loraikan yang dia cover semua yang overlap, ya, bahagian yang overlap. Faham tak ni? Okay, kalau tak faham nanti boleh tanya lagi sekali. Alright, so your final region, your final ROC is the overlapping of all of that 3 poles tadi tu. So this is you punya final ROC. Okay. Alright. Now we look at inverse Z transform. Okay, kita nak tukar daripada Z transform kepada sequence. So what is Z transform ni? It's an operation to recover back time domain signal from the Z transform lah. Okay, usually we use the circular integral or contour integration, but what we can do is, because we have that table kan, so you can use inspection method, and also in several cases you kena guna partial fraction expansion and then or power series. Okay, for the inspection method, okay, basically you refer to the table again, and then apa yang you buat is you look at the similarities lah. Okay, so for find the inverse of xz, so you tengok dekat table, you see that it is similar to apa ni, this is the Z transform sama, so this is the punya sequence. So what you have to do is write out the sequence. Okay, write out the sequence. So dekat sini plus the tunjuk dekat sini, it is Z bigger than 1/2 kan. Okay, so means you tahu this is apa ni, so bila nak tahu yang mana satu nak pakai kan tadi. Okay, so you kena tengok dia punya ROC lah. ROC ni, so ROC dia sama, then you dapatkan dia punya Z transform. You tahu mana Z transform nak pakai, and you tahu mana sequence nak pakai. Okay, so you tengok ROC dia. Sebab tadi kalau if you remember from the table, okay, from the table, this one dia punya Z transform sama, okay, but ROC dia berbeza, so sequence dia pun berbeza. So Z transform ni sama, so which one nak pakai ni? So tu tengok ROC dia. Okay, so tadi ROC dia bigger than 1/2 kan, so this one dia punya sequence. Okay, alright. Okay, so this is your answer. Right, the next one, okay, sama juga tadi. You tengok this is the Z transform, and then this is the ROC. So ROC dia adalah smaller, so this is smaller than Z. A is smaller than Z, so means that it is a left-sided sequence. Okay, so you tengok this apa ni, this is the sequence yang you kena ubah. So this is your ni lah inverse Z transform. Okay, so referring to the table, mana you nak tengok, you kena tengok ROC dia dahulu. Okay, so partial fraction expansion. Okay, since this is a rational equation, so so xz given by dia punya, this is pz over qz, base is numerator dia and denominator, zeros and poles, yeah, zeros and poles. Okay, so you have n bigger than m with different poles, m bigger or equal to n with different poles, and then you have n bigger or the same as m with multiple poles. So we are going to look at this two first. Right, a Z transform given as xz 1 over equation polynomial ni with ROC Z between 3/4 to 2. Okay, Right, so you have you tulis balik semula persamaan yang diberikan, and then you buat you factorize the polynomial. So you have this factorized polynomial. Pecahkan A plus B. Alright, then what you need to do is we need to find for A. So for A, kita nak cari untuk A. Okay, so what you need to do is we look at just this part. Okay, this part. Alright, so you multiply, okay, all of the equation with 1 over the denominator of A. So darabkan semua. Okay, so bila darabkan semua, you can see that you this one boleh cross. Okay, for cross, and then you get persamaan yang ni akhir sekali, and then Z gantikan dengan the poles in of about denominator of A ni. So dekat sini gantikan Z equals to negative 3 over 4, and then you have here 3 over 4, so nanti you dapat ni jadi kosong. Alright, so A equals to 1 over 1 minus 2Z to the power negative 1, gantikan Z dengan 3 over 4, so you dapat persamaan ni, and then you kira you dapat A equals to 3 over 11. Alright, so and then the next one, okay, kita cari for B pula. Okay, so this is for B. Okay, so kita tengok this bahagian ni saja. Okay, so for this part, so you multiply all this with the denominator of B. So bila you dah multiply, okay, so you can cross this and you can cross this. So you have B. Then gantikan all the Z, you rewrite the equation 1 over sekian-sekian, okay, A times sekian-sekian plus B, okay. Then you gantikan all the Z with the poles from B. So Z is equals to 2. Okay, equals to 2, and then you have B sama dengan 8 over 11. Okay, so you have to do this slowly. Do it on paper several times so that you can get the idea. Now you dah dapat. Okay, so you have tadi this kita tulis semula the equation tadi yang you dah factorkan, and then you have x z equals to A plus B ni. Alright, and then you gantikan nilai A dengan B. Okay, and then you see that you have you punya apa your denominator you asingkan dia punya perkali ni. Alright, so you have this form, this form that is similar to the one in the table. Alright, so difference equation is given by Z to the power of negative 1 xz, so you dapat xn tadi, so refer pada table. So this part tadi, okay, is similar. So which one you nak pakai kan? You kena tengok tadi lah dalam soalan, dia soalan dah bagi tahu. Soalan dah bagi tahu yang ini. Alright, ROC is such and such. Okay, so ROC is between ROC is between ROC is 3 over 4 2 So dekat sini you tahu that okay, Z is bigger than 3 over 4. So yang poles yang Z is bigger than 3 over 4 is right-sided sequence lah. Okay, so for this part, you kena pakai yang untuk causal ataupun right-sided sequence. Okay, yang ni. Okay, and then for the second term, okay, Z is smaller than 2. Okay, bila Z is smaller than 2, ROC is smaller than 2, then you must use the yang line number 6 ni. Okay, alright, so then this is your final difference equation. the final difference equation. Okay, boleh faham Right, so tengok dia punya ROC to find the correct inverse Z transform. Alright, so daripada sini nak tengok dia punya ROC, kita dah bagi tahu kan. Okay, so ROC tadi dia dah bagi tahu. So you draw you punya Z plane. So you have IM, now you have RE. Okay, so you have you punya unit circle. Okay, this is a sketch so tak perlu cantik sangat, sketch saja. Alright, so and then you have paling besar sekali 2, so kata this is 2, very tak scale lah, tapi sebab nanti buat lawa-lawa sikit lah bila you menjawab soalan. So this is 3/4, okay, maybe around here. Okay, so 3/4. Okay, you don't have to worry sangat pasal dia punya positive and negative tadi tu, because you are going to draw apa ni, all the annular region so means that dia poles dia for ROC lah. Kalau for poles memang you kena tanda lah, tanda X tu dekat sebelah sini ke sebelah kiri atau kanan and then so dekat sini is bigger than 3/4 but smaller than 2. So smaller than 2 dekat dalam, bigger is kat luar lah. So it's in this region. So you have a donut ROC lah. Okay. Alright, so this is you punya ROC. Okay. Right. So let's look at another example. Right, this example pun lebih kurang je. So you have a Z transform is given x z and ROC is bigger than 1/2. So you have here, and dia punya order of the denominator is bigger than the order of the nominator So dekat sini again you factorize the polynomial, the denominator. Okay, then you keluarkan, you tulis dekat dah factorize. So you tulis begini. Okay, right, so kita buat satu persatu So we want to find for A. Tengok pada term yang ni saja. Okay. Alright. So we want to find for A. That means kita kena darab semua ni dengan denominator of A. So once you dah darab, you darab ni, so you can cross yang sama ni kan. Okay. Then you gantikan Z equals to 1/2. Right. So bila dah gantikan, you selesaikan for this persamaan, you get A equals to -9. Alright. Then you tengok for B pula. Alright. So again for B, we look at just this part for B. Alright. So you times multiply the equation with all of the denominator of B. So then you can cross out all this. Okay. Rewrite the equation and then gantikan the Z to the poles from B. Z equals to 1/3. So selesaikan, you have B equals to 10. Okay. Right. Then you have okay. So you gantikan dalam persamaan. Okay. And then difference equation dia. So kita buat satu persatu lah. So you buat first term yang pertama. Okay. Term yang pertama dan term yang kedua. So again, macam mana nak tengok tadi tu? Dia kata ROC is Z bigger than 2 kan? Okay, Z bigger than 2. So dekat sini, semua tu adalah right-sided sequence. Okay, then you guna persamaan yang ni saja. Right, so you use this term. Dan buat satu persatu. Okay, so you have here Alright, so this is salah sikit kat sini lah. Alright, so nanti betulkan lah ya. This one is a bit salah, dekat sini ada salah sikit dalam slide ni. Z bigger than 1 over 2 Z bigger than 1 over 2. Z bigger than 1 over 2. So you have, let's see, tadi tu 1 over 3, 1 over 3. Okay, so ni bawah ni ada this one. This one ada mistake sikit lah. This one, this part is okay. Use this one Alright. Jangan confuse pula, sorry. So xz equals to persamaan ni ni ada salah sikit. So gantikan, alright. So 1 over 2 dia punya a, then this is 1 over 3 a dia. Okay, gantikan, then you have your xn. Alright. So how to sketch you put for you punya ROC sama juga macam tadi. So you have, you sketch your z plane. Okay, so you have 1, and then you have 1 over 3. Sorry, 1 over, so this is 1 over 2. This is 1 over 3. Teruk betul sketch ni. So this is 1 over 3. Ni kurang This is 1 over 2. So it is bigger than 1 over 2, bigger than 1 over 3. So overlapping region here, it is bigger than 1 over 3, is bigger than 1 over 2. So overlapping region dia adalah dekat luar ni lah. Okay, what bigger than bigger than 1 over 2. So ROC tadi macam dalam soalan lah, is bigger than 1 over 2. Okay, so that's the bentuk of the ROC. Okay, let's look at the, okay, so itu we stop here dulu. Okay, and that is the inverse Z transform. If you don't understand, if there's part of that you need some more clarification, boleh bagi saya soalan through your your representative, or you can DM me, no problem. Okay, thank you. Hi students, so we are back to the next session. Right, this is we have looked into the inverse Z transform using the inspection method. Then we have looked the Z transform, inverse Z transform using the partial fraction expansion, and then we have now we look into the power series. So xz, okay, is apa ni adalah summation of xn times 2 z to the power of negative n. So if we remember, okay, from the previous class, okay, so we have n, okay, and then you have xn. Alright, so dekat sini xn are coefficients of z to the power of negative n. So this is coefficient dia lah, value pada n minus 2. This is value pada n minus 1. This is value pada x kosong, n kosong. This is pada n1, n2. Right, so therefore we can find the series expression for xz by simply picking off dia punya coefficient saja. So this is where kita boleh tuliskan xn, okay, dalam bentuk jujukan nombor. Okay, jujukan nombor apa sajalah, 1, 2, 3 dan seterusnya lah kan. Okay, so kita tahu bahawa setiap nombor tu, this is n equals to kosong, this is n equals to 1, 2 dan seterusnya. Dan kalau misalnya ada value yang ni, this is n negative 1 and negative 2. Alright, so in this case, bila kita tak ada, we use this method when we find that the xz is a simple polynomial. Okay, right. So for example, kita tengok the inverse, for kita nak cari inverse of persamaan ni. Okay, so although this is a rational function, tapi pokok dia hanya ada pada 0 saja. So partial fraction expansion is not appropriate lah. So from here you can see so dia punya xn adalah sini nilai dia 1. Okay, nilai dia 1, nilai dia negatif 1, nilai dia 1, nilai dia negatif 1, 1/2. Alright, so kalau kita nak tahu location of this the coefficient is we look at the delay. So when we look at the delay, right, so this is 2, so it means that dia punya n adalah negative 2. This is 1, so n dia adalah negative 1. This is 0, okay, because remember z to the power 0 means that z is then gives you 1. So bila n z to the power 0, so n adalah kosong, z to the power negative 1 means that n adalah 1. So ni adalah coefficient yang ada pada depan z. Okay, you senaraikan. So this can also be written as xn equals to 1, negatif 1/2, negatif 1, 1/2. Okay, so n dia adalah sini n negatif 2, n negatif 1, n kosong dan n 1. So kalau kita tengok ni, means that n kosong bukan lagi berada yang paling kiri kan. So kalau ini kita boleh tuliskan sebagai, lukiskan arrow di bawah n sama dengan kosong tadi, ataupun pada coefficient n sama dengan kosong. Right? So when we write when we do the inverse Z transform, so remember when we do inverse Z transform, that means xz becomes xn. Okay, so from the table kita tahu delta n is 1. Okay, delta n is 1. So dekat sini, and if you look at the properties pun, okay, kita tengok table tu sekejap. Where is the table? Let me find the table. Jauh table. Alright. So this is ni properties Okay, so table delta n is 1. And then kita tengok properties dia dekat sini. Kalau xn jadi xz. Okay, but this is for kalau ada coefficient, kalau tak ada coefficient ni lah. Right. So okay, abaikan bunyi tu. Alright. So here we look at this. So delta n sama dengan 1 So xn tadi jadi xz. Okay, so that is the table. Kita tengok pada table tadi. So here you see that delta n, okay, so sini 1 tadi. So delta n, kita ni tengok delay dia. Delay dia adalah negatif 2 kan. Negatif 2, so delta n plus 2. Alright, so here is delta n, coefficient adalah negatif 1/2. So, and then dia punya delay adalah negatif 1. So, delay dia adalah delta n plus 1. So, ingat Kang lupa pula. So, delta n bila ada shift is n minus nd, delay. So, dekat sini yang dia jadi positif ke negatif tu. So, bila dia negatif, so this is jadi positif lah. Alright. So, and then 1 negatif delta n. Okay, 1 this one. Okay, so tak ada delay, so delta n saja. Then you have this part, this one adalah tambah 1/2. Okay, so delta n minus 1 sebab dia delay 1. Alright, so this one is clear Now, we look at the system function ataupun transfer function. Okay, so for yn, output dia adalah hasil daripada impulse response darab dengan input. Okay, and then kita tengok dia punya, this is the frequency response dalam bentuk frequency response, and then this is the Z transform. So Hn is impulse response. exponent J omega is frequency response, Hz is system function atau transfer function. Bila kita nak tahu satu-satu sistem itu adalah causal, okay, so kita tahu kan causal tu right-handed sequence and must start dengan n equals to 0 atau n bigger than 0. So dekat sini, the system to be causal, okay, response must be response Hn equals to 0 pada n lower than kosong. So means that dekat sini n, this is Hn, okay. So n yang kurang daripada kosong ni kosong kan. So ni semua kosong. Jadi value dia hanya ada pada sebelah kanan saja. So that's why this is causal. So a pole inside the unit circle, contributes to an exponentially decaying term. Okay, so this impulse response dia akan jadi ke bawah, exponentially decay. A pole outside the unit circle, so this is let's draw this one. So you have the unit circle, this is pole dia dekat dalam unit circle, so a pole inside the unit circle, then gives you a decaying impulse response. And then if the pole is outside the unit circle, so you have unit circle, the pole is outside the unit circle, so it will give you a term that is resulting, a term that exponentially increasing. So dia punya value gitu. Alright, so the ROC of a causal system extends outside the outermost pole. So kalau causal system, okay, causal system dia punya ROC must be, okay, ni katakan this is the outermost pole, so dia punya ROC di luar, okay. So okay, this one, right. So kalau when a pole is inside the unit circle, so ni kat luar ni unit circle tadi kan, pole kat dalam, so this means that ROC dia outward, okay, dia cover unit circle, so dia adalah causal dan stable. So ingat ya, kalau dia nak dia adalah, when it is causal dia outward, okay, bila dia stable means dia kena cover, ROC tu mesti ada unit circle, okay. Now if a pole is outside the unit circle, okay, so the pole is outside the unit circle, therefore dia punya ROC pula keluar, ke arah outward, so unit circle dekat dalam unit circle di luar region ROC ni. So it is a causal system but it is unstable because tak ada unit circle dia bukan berada dalam ROC. Okay. Okay. For a system to be stable, kalau satu-satu sistem tu stable, dia punya impulse response is summable and dia punya DTFT adalah exist, means dia boleh di-calculate, ya. Now, LTI system is stable if and only if ROC of its transfer function, okay, includes the unit circle. Macam saya cakap tadi, you must include the unit circle. So a pole inside the unit circle contributes to a right-sided decaying system. A pole outside the unit circle contributes to a left-sided decaying system. Note that a stable impulse response cannot contain any increasing exponential or sinusoidal terms, since the impulse response is not absolutely summable. Maksudnya, okay, kalau kita tengok dekat sini, macam tadi example yang sama tadi, lebih kurang sama. So bila dia adalah when a pole is inside the unit circle, so ROC dekat luar kan, so dia adalah causal and stable sebab dalam ROC ni, dalam ROC ada unit circle, okay, dalam bahagian lorekan ni ada unit circle. Now kalau and then dia punya impulse tu, dia exponentially decay, means lama-lama dia akan jadi kosong. So a pole is outside the unit circle contributes a left decaying term to the impulse response. So kalau dia di satu sistem yang okay, so when uh, sorry, a pole berada di luar unit circle and then it is anti-causal. Okay, bila dia anti-causal, so ROC is inward kan? ROC is inward, so dia punya decaying system, left-sided decaying system. So dia start daripada kosong, dia naik sini kan? Okay. So this will give you also a system that is walaupun dia anti-causal, dia adalah stable, because again dia punya key dia adalah if the ROC, okay, ROC dia contains unit circle, the system is stable regardless dia causal ke anti-causal, as long as ROC dia ada unit circle. Okay, right. Now, causality and stability. Okay, a causal system's ROC lies outside of a pole circle. If that system is also stable, ROC must include unit circle. Berapa kali nak ulang ni? Alright, so for an LTI system to be both stable and causal, ROC must be outside the outermost pole and include the unit circle. Yang macam kita dah tengok tadi lah. Clearly, a realizable LTI system, if is both stable and causal, must have all the poles inside the unit circle. So, kalau yang paling sesuai dia adalah bila sistem tu adalah causal dan stable, sebab dia punya causal and stable, because dia punya impulse response tu menghampiri kosong. So kalau dia begini, walaupun dia stable, dia tidak realizable because nilai dia makin meningkat ya. So dia macam diverge gitu. Alright. And then a pole inside the unit circle is a right-sided sequence decaying system, anti-causal system that is stable if and only if poles lies outside the unit circle. Sebab kenapa dia cakap macam tu? Ialah sebab anti-causal system dia kan inward. Bila dia inward means that poles dia mesti berada di luar unit circle untuk include unit circle kan? Macam gambar tadi lah. So dia mesti di luar unit circle supaya dia boleh cover, okay? Dia boleh cover ataupun overlap dengan unit circle. Right, poles on the unit circle will give you a complex sinusoidal terms which is unstable. Kalau poles tu adalah sama dengan satu, then you get an unstable system lah. Alright. A system that is both stable and causal must have all its poles inside the unit circle in the Z plane. So macam if you have a transfer function, okay, and then the outermost pole, the poles must be inside the unit circle. All of it must be inside the unit circle. So let's see. Okay, an LTI system has the transfer function berikut. Find the impulse response if the system is stable or causal. Okay. So the poles ni, so ada banyak poles ni. So you have the poles being at this positive 0.9 ni, and then you have negative 0.9, alright, negative 0.9 pada point 0.9 at E exponent negative J pi over 4. So this is, and then you have, this is the unit circle, and then you have 2. So kalau dia nak causal tadi, dia nak stable. So kalau kita letak untuk answer for A ni stable, for the system to be stable, ROC must include the unit circle. So the two poles inside the unit circle contribute to right-sided terms to the impulse response, while the pole outside the unit circle contributes to a left-sided term. Hence, for A, okay, for A, dia mesti apa ni? Dia mesti satu, this part is this part is causal. Okay, kalau causal tu means that dia akan outward, and this part will be inward. Alright, so what you have here, it will be like this lah. Nanti you punya ROC begini. So you have tadi poles tu dekat di sebelah sini kan, atas bawah, and then you have your unit circle. Alright, then you have a bigger, this one, ini dua tadi. Okay, dua. So this is your unit circle. Okay, unit circle. Right, so dia kata tadi, the two poles inside the unit circle contributes to a right-sided terms to the impulse response. So here, okay, this part will give you, will go outward. Okay, and then sampai dekat dua ni, this is inward. Inward. So dia akan you dapat donut, dalam bentuk donut. So this one is stable, and dia adalah two-sided sequence, two-sided sequence. Now, if the system is causal, then all the poles contribute to the right-sided terms to the impulse response. So we have so all the terms ni must be outward lah. So dekat sini, so again saya lukiskan, bear with me lah. Alright, the sketch saya ni tak berapa kemas. So you have your unit circle again. Okay, this is unit circle. Then you have two tadi, kat luar ni, two. So here, right, this one is outward. Okay, and then this is also outward. Kan, out daripada dua. Alright, so dekat sini, at the end, you will have satu ROC dia adalah kat mana? ROC dia adalah, sorry, this is yang tadi, poles tadi, and then you have unit circle, then this is 2, okay, it's 2, you punya ROC adalah di luar sini. So, ingat ya, overlapping region. So overlapping tu, pertindihan tu berlaku di luar 2. So your unit circle dekat mana? Tak masuk dalam ROCU. So bila dia tak masuk dalam ROC, so it is causal, tapi dia tidak boleh jadi stable. Okay, so that for this particular system, tidak boleh jadi stable and causal, because ada pole di luar unit circle ni yang causal. Okay, right, so I hope you can understand, and if you have any questions, please don't hesitate to ask me. Thank you.